Everything NASA wants to build on the moon rests on one thing that it can't see: the ground a few meters down. China just looked. It isn't the platform it looks like from orbit. Their rovers pointed radar straight into the surface, and what came back was layered and uneven. Boundaries at different depths, regolith that shifts from one spot to the next, weak zones that never show up from orbit. The plan now isn't to land, it's to build. Habitats, landing pads, power systems, the machines that dig and anchor everything in place. Every one of them assumes the ground will hold. China's radar is the clearest sign yet that this is the hardest part of the whole plan. The animation always shows the same thing. Astronauts land, habitats unfold, the lights come on. What it never shows is the few meters of ground underneath that decide whether any of it lasts. For a long time, the moon looked like a closed case. Apollo put 6 crews on the surface, ran experiments, drove a rover through the dust, and the ground held them fine. But the longest stay, Apollo 17, lasted about 3 days. A base is a different promise. Structures meant to stand for years, anchored against the shock of everything landing and the slow settling of ground that has never carried this kind of weight. Chang'e 4 made that harder to ignore. It was the first mission ever to land on the moon's far side, and its rover was the first to aim radar straight down into that ground. The surface came back in layers, irregular and uneven. Nothing like the solid ground it appears to be from above. Chang'e 3 taught the opposite lesson. Even radar can mislead you. Some of those deep layers were later argued to be signal artifacts, not real structures. The moon's interior is hard to read even when you are sitting directly on top of it. That is where building stops being a surface problem. A habitat engineered perfectly on Earth is still in trouble if the soil settles unevenly once it is down. A few centimeters of tilt strains the seals and stresses the joints that hold air inside. A landing pad can sit on ground that looks flat and firm right up until repeated landings crack it and fling debris into everything parked nearby. A weak layer a few meters down rarely stays a geological footnote. It becomes a damaged pad, then delayed cargo, then power, shielding, and mobility, all slipping behind schedule. One quiet flaw underground works its way outward through the whole base. On Earth, you fix it with more crews and more concrete. On the moon, every correction costs launch mass, astronaut hours, and risk you cannot easily buy back. A small mistake below the surface hardens into a permanent constraint above it. Structure is only the first problem. The same uncertainty runs through everything a base would live on. Water, ice, oxygen, raw material for building. None of it is spread evenly across the moon, and spotting it from orbit is nothing like reaching it below. Dig for ice, and the machinery can meet ground that is harder, softer, or colder than models promised. It can jam, sink, or stall. A drill built for one density binds in another. A scoop size for loose dust stalls in a compacted layer. There is no resupply truck nearby. The gear has to work the first time in conditions that no one tested it against. If that work stalls, oxygen and fuel production slow with it, and the base leans harder on every shipment from Earth. Even holding a habitat at a survivable temperature depends on knowing how heat moves through the local ground, and a hidden void or a porous layer can rewrite that in ways no orbital map would catch. Then radiation changes the shape of the problem. The lunar surface takes the full weight of cosmic rays in solar storms, with no atmosphere and no magnetic field to soften the blow. Any long-term base needs real protection. Regolith piled over the structures, thicker walls, or part of the base tucked underground. Building that protection from scratch costs mass, time, and machinery the mission may not have to spare. And here the ground flips. The thing that threatens the base from below is also the thing that can shield it. The evidence for that is no longer only China's. Researchers reanalyzing radar from NASA's own Lunar Reconnaissance Orbiter found something striking beneath the Mare Tranquilitas pit, about 400 kilometers from where Apollo 11 first landed. Signs of an accessible cave, a conduit running tens of meters under the surface. Published in 2024, it became some of the strongest evidence yet for an accessible lunar cave tied to a lava tube-like structure. The inner pit is roughly 100 meters across and about 105 meters deep. Thermal modeling suggests shaded interiors can stay around 17 degrees Celsius, while the exposed surface outside swings between roughly 127 degrees Celsius and minus 173 degrees Celsius. A space like that is close to what a base wants: natural cover from radiation, from micrometeorites, from the violent swing between lunar day and night, without building all that shielding from scratch. Find enough of these mapped and proven safe, and the first base may not be built on the moon so much as moved into it. A cave only helps if you can trust it. The roof has to hold. The walls cannot be fractured in the wrong places. Its collapse history matters as much as its shape, and none of that shows up in a single radar pass. It takes mapping and modeling long before a crew ever steps inside. A roof that looks intact can still be threaded with stress fractures from billions of years of impacts. The same hollow that might shelter astronauts could just as easily swallow them if no one has charted it first. Underground, the difference between a foundation and a trap comes down to one thing: knowledge. If you want to understand how space infrastructure actually works, not what gets announced, but what quietly decides whether it survives, subscribe to SpaceWatch. The visible mission is usually not the real story. The phase that decides whether it lasts happens years before anyone turns the first shovel. And the next target makes that harder, not easier. NASA wants to build at the lunar South Pole, but the part of the moon humans most want to build on is one of the parts we understand least. Much of the best in situ radar data so far comes from the far side and mid-latitude plains, not the pole. The polar terrain is its own puzzle. Older, heavily cratered, shadowed in ways that keep it hidden. Some crater floors there have not seen sunlight in billions of years. Cold traps where water ice may sit locked in the regolith. The clearest radar comes from rovers on the surface, not orbiters above it, and reaching the pole's frozen, cratered terrain with one is harder than anything. Apollo attempted, and that is exactly what China's next missions are built to close. Chang'e 7 is planned to launch toward the South Pole with a rover carrying penetrating radar to study that ground up close. Chang'e 8 is meant to follow, testing whether you can use what is down there, pulling resources from the soil, even printing building blocks from lunar dust. This is what comes before a base, proving the ground will not become the first failure. So the real first phase of lunar construction is verification. Radar mapping, stability checks, resource surveys, thermal models, and trial digs into ground no one has touched. The milestone everyone will see is a habitat on the surface. The mission that decides whether it lasts begins years earlier, in the invisible work of proving the ground can be trusted. Landing on the moon may turn out to be the easy part. Building on it is the hard one. The radar has already shown where the answer begins. A few meters down. NASA still has to go get it.